Good afternoon, everybody. Myself, Rajat Sadhukan. I am a PhD student at Indian Institute of Technology, Kharagpur, working under supervision of Professor Devdeep Mukhopadhyay. My PhD thesis title is Design Automation for Side Channel Resistant Lightweight Cryptography. As you know, our future will be next controlled by IoT devices, and all these devices are connected, and if an attacker gets access to the network, then the whole communication system will get jeopardized. In 2017, Adi Shamir and his team demonstrated such an attack on network of lights manufactured by Philips. So you can see a drone at a range of 350 meters flying up to a building, taking control of all smart bulbs at the city, and one infected bulb in the network can infect all other bulbs in the network, and within minutes the whole city can be permanently switched off. So this motivated us to work in this direction, where we augment the classical EDA flow with security aware notions such that addressing these challenges can be addressed during the manufacturing process itself. Our first work is machine learning based power efficient SBox synthesis, where we first develop a machine learning based classifier to determine if the SBox is power efficient or not, and then based upon the developed classifier we built a deterministic model to predict the dynamic power of SBoxes. Our methodology is 80% accurate, and assuming that we have a list of 2 to the power 20 SBoxes and finding the power efficient from that list, a commercial EDA tool will take around 4 to 5 months, but our tool will take 10 days to get the power efficient SBoxes from such a huge list. Our next work is pre-silicon power analysis of crypto design. This basically the side channel analysis is carried at post silicon stage, and if such design is found vulnerable, then it incurs heavy loss. So our leakage model computes dynamic power using toggle count of circuit nodes, and this is in the pre-silicon stage, where it can be exploited by circuit designers to early detect if the circuit design is vulnerable to leakage or not, and by tool developers to make their flow security aware. Our third work is differential fault attack aware floor plan, where we propose fault attack aware floor plan to mitigate threat posed by DFA. This work exploits clustered fault model of fault injection methodology, where exploitable fault should be at r distance apart. You can see we have experimented on AES blocks, where the diagonal blocks are placed r distance apart, which are very sensitive to faults. So if you can see, and the other blocks are placed close to each other. So these are